Hello everyone, good evening. Today we will talk about Delta Lake. Delta Lake in Databricks. First, before talking about the Delta Lake, we will briefly understand about lake houses, data lake houses. See, these data lake houses leveraged a special storage framework which allows to store data both in table format and also you will be able to store your raw data as it is. It is a one platform for you where you can put your raw data and also same time you can access your data in tabular format. But the lake part of these data lake houses especially, they suffer from certain inconsistencies, inefficiencies. Especially, there are some challenges in processing big data. And we observed them. One of the major drawback with the regular data lakes is ACID transactions. Like databases, data lakes, they don't follow strict ACID transactions. Like no proper atomicity, consistency, there will not be any isolation. Of course, the durability part is good in data lakes, but the read write, when concurrent read write things are happening, they might collide with each other when people are trying to write data and the same time to read data. When concurrent transactions are happening like that, there might be issues. Like this, there are a lot of issues, especially with ACID transactions. And that's where a concept called Delta Lake has been proposed. In this Delta Lake, it's a data lake house. See, traditional data lakes, they have issues. Now, to resolve those issues, data lake houses like Delta Lake came into existence. Sorry, Delta Lake. Now, what is this Delta Lake? Delta Lake is a open source storage layer that brings some reliability to the data that is stored in data lakes. Reliability in the sense, if you are saving your data in the data lake as it is, it's not very reliable. So Manajas, what is this lecture about? This lecture is about understanding Databricks. It's about the platform Databricks. And this Databricks is a data lake house. Data lake house in the sense, I would start about databases like MySQL. You know about MySQL databases. They'll save your data in tables, right? Manoj, is it related to prompt engineering? No, it's about data engineering, Manoj. As a part of data engineering, Databricks is a specialized platform. And we are talking about this Delta Lake, which is related to Databricks. Okay. Anyways, let me set the context. Today, we are talking about Delta Lakes, which is nothing but a framework, storage framework, how to save your data. We are familiar with databases. What they'll do, databases like MySQL database, Whenever you put data into MySQL database, they'll arrange your data into rows and columns tables. Suppose if it is NoSQL database, they'll try to arrange key value pairs according to the type of NoSQL database, graph data. That's why we call them as DBMS, database management software. Now, when data has transitioned into big data, only databases are not enough to save all the big data. We need storage solutions which can save data as it is, because data coming in different formats from different sources. It's structured, unstructured, semi-structured, and multiple sources. IoT data, social media data, application data. Now again, it's big data. It will come with high volume and velocity. We cannot spend our time in arranging this data in tables directly. Rather, data engineers choose to save this data in object stores and data lakes. If you are someone who are not aware of what data lakes or object stores, you might have used your Google Drive. What kind of storage it is? It is a storage where you can save your files as it is. Yeah, that is our discussion. How Delta Lake different than data lake. We will talk about it. Now coming to the data lakes are there. They support this concept of saving your data as it is. You can put your CSV file, PDF document if you want, your JPG image if you want. Whatever data is coming, you can just dump it in your data lakes. Just like how you put in your Google Drive. Of course, the support is given by Google, like Google Slides, Sheets, Spreadsheets, Docs. Other than that, if you look at it as a plain storage, you can save anything in it. Data lakes are also similar kind of storage. Of course, with additional data integration support and all. Now, what is the drawback of this data lake? These are good for saving bulky data. They support both structured, unstructured, semi-structured, all kind of data. But the drawback is they don't follow ACID transactions. Suppose some file is being written to the data lake. It is some 10 GB file. In midway to some reason, the upload or insert, it was not complete. It was halfway done, half uploaded and half didn't upload it. Data lake accepts it because there is no atomicity. Suppose if it is a MySQL database, if you are doing some export to MySQL database, the same thing happens. MySQL will not treat it as a complete one. Either you have to do the complete transaction or nothing. There is no midway transactions to the databases, but in data lakes, that is a problem. You cannot apply any consistency rules on your data, like business rules. You cannot say that sales data should be, let's say, order data should be always greater than 1. You cannot check this on data lake because you are not organizing your data. You cannot impose such rules on your data on data lake directly. It is a raw storage. You are just dumping your files there. That is data lake. We have AWS S3. So you can build a data lake around S3. You can put anything into the S3. And in Azure, we have blob storage. And in GCP, we have GCS, Google Cloud Storage. And these are some popular examples for such kind of storage. And there are many. Suppose if you want to build on open source, HDFS, Hadoop Distributed File System. You can save any kind of data, but you cannot expect ACID transactions, atomicity, consistency, isolation, read-write happening concurrent. We cannot expect data leak to intervene and take a responsibility that both read-write operations are happening on the same file. So 10 GB file, 5 GB has been came, and some other guy trying to read it, that 10 GB file. Write is happening and also read is happening simultaneously. So if it is a database, it will not allow this read operation to happen on the file that is in midway. It's not yet complete. So there is no strict rules on concurrent operations. All these are the issues with data lake. They are good for storage, storing bulky data, terabytes, petabytes of data. But when coming to these kind of rules, people used to struggle the data lakes. And what here data engineers used to do, they get data from the data lake, they transform and they used to write into the data warehouses, that is in tabular format, which provides better ACID transactions when compared with delta lake. And there are two platforms. Now data engineers have to make use of two platforms. One is data lake to store raw data, and another one is data warehouse, where we will be able to store the data in structured format, in format of tables. And this concept called delta lake came then. Why making use of two different things, data lake and data warehouse? Let us club both of them. We will call it as data lake house. We have platforms like Databricks, Snowflake. These are some examples of data lake houses. Meaning, if you have a CSV file, if you want to save it as it is in its .csv format, you can save there in the data lake part of that storage. The same CSV file, if you want to export into a table, right? You can also do that, because there is a data warehouse part which allows you to write your data in form of tables. And delta lake is one such concept that allows you to build the data lake. So data lake is nothing but delta lake. Data lake house is nothing but the delta lake. And Databricks is one particular platform which is based out of these delta lakes. It's nothing but a open source storage. Sorry. Yes, the text was hidden. My bad. Okay. Delta Lake is an open source storage layer that brings reliability to data lakes by adding transactional storage layer. What it is, we will discuss. What is this transactional storage layer? So data lake plus data warehouse is equal to delta lake. Exactly. By adding the data warehouse part to your data lake, the more reliability, the ACID transactions, better ACID transactions are available to data lake part also. We will take some scenarios and understand what is the difference between the traditional data lake, that means you can dump your data as it is, that's it. You cannot manage the atomicity, consistency. You cannot ensure that the operations are happening in isolation. When these warehouse part is also added to the data lake, they have better ACID transactions. How? We will discuss some scenarios. This is achieved by adding something called as transaction log. Now, log means log files. They tell that there is some continuous monitoring or continuous collection. When such a kind of thing happens, we call them as logs. So transactional log is something that logs all the type of transactions that happens to your delta lake. So we have delta lake, delta table. That's what we discussed. It's a lake house. And delta lake part is a place where you can save your files as it is in its raw format. And delta table part is where you can structure your data. That is delta lake and delta table. Now, whenever you put some files into this cluster of delta lake and delta table, a transactional log will be associated. And one more thing, this delta lake tables especially, they are columnar based storage. So the underlying files are stored in Parquet format, which is nothing but column wise data is stored. Now these are the things you have to remember. Delta lake is nothing but data lake house. Data lake house is nothing but it has two components, the lake part where you can save your data in its raw format, and the table there you can arrange your data in rows and columns. And here we have something called as transaction log. The changes which you make to your data, read, write, insert, delete, update operations, all will be collected in the form of transaction logs. And these transaction logs are key to maintain the status of the tables here. See, every time when you do some transaction with the table, you inserted data. In my table, say for example, you created some table called my table, you inserted data into that table. Immediately, a .json file will be created. That file is log file. And what data you have inserted, at what time you have inserted, all these details will be available in that .json file. These are called transaction logs. Now, let us talk about writing and reading scenario. There are two characters on my screen, Alice and Bob. They both are working with Delta Lake. This Delta Lake, Alice, has inserted some record into the table. And her record has been added to files also, like part 1, part 2. She has added some 2 files or some bulkier file that has been splitted into 2 files as part 1 Parquet file, part 2 Parquet file. And once this insert operation is success, she'll get a success message. Before even sending the success message, what happens here is a transaction log will be created. This transaction log will be having the details on how this transaction happened. It's an insert transaction. What type of transaction? Insert. And how many files inserted? 2 files inserted. At what time? Some time when it happened. All these kind of information will be available in this transaction log. So how it is helpful? We don't have this in traditional data lake. So people used to struggle a bit. Now in Delta Lake, we have this kind of tracking through transactional logs. Now Bob will try to read it. Select everything from table. See, the table is built on top of these 2 files. Now what actually should Delta Lake do? It has to fetch all the data from the table, but it will not do that. Before that, it will go to transaction logs. It will check the transaction logs. It comes to know that a insert operation has been done. So it will check what inserts has been done. And after that inserts happened, it will treat the table status as the latest one. And it gives all contents from the table, which includes Parquet 1, Parquet 2. Before that, there used to be some files, right? On top of that, there is a table on top of that files. Alice inserted new things, new files. So this is not a traditional row insert. Alice is not inserting them as a row. Alice is inserting them as files because it's a lake house. It's not database. When she says insert into, her data will be splitted into two Parquet files. And also those Parquet files will be available as rows in the table. It's very different from traditional databases. Now Bob, when tries to read it, first it will check the transactional log to know the latest status of the table. And it will read the data files along with the inserts part 1 Parquet, part 2 Parquet. Now let us take one more scenario. Updating scenario. See, databases are different from data warehouses. And data lake houses are also different from traditional data warehouses. Now, if you take this delta lake concept, here when you put data, you will put it in form of Parquet files, right? Especially when you want to create table, you have to make them as Parquet files. Of course, there is a data lake part of it in the delta lake. There you can save any kind of data. But when you want to create table, for example, a CSV file is there, where in the data lake. Now it's a structured data. I want to view it in table in the same place in the delta lake. So what delta lakes does for us, it converts CSV into Parquet, and that Parquet is used by table. So you should understand this. And Parquet files are immutable. See, these are all for analytical purpose, not for transactional purposes like our databases. In analytical storages like data lakes, data warehouses, the read write operations will happen, but update operation, they happen very rarely, because in most of the cases, if you are collecting data for data analysis, they are already happened or they come in real time, like sales data, orders placed, already census recorded the IoT data. There won't be any changes, updates. How difficult is to convert CSV to Parquet? It's very easy. Even in your local, you can convert CSV file to Parquet by just with few lines of Python code. When coming to Delta Lake, it's not your job. Delta Lake will take care of it. It's a cloud managed one. Databricks, right, is a cloud, and it's hosting the Delta Lake. They'll take care of it. When you try to load your CSV file into the table, you'll get it. But in the backend, what happens is they'll convert CSV to Parquet. On top of that, they'll create table. That happens in the backend. But you have to understand the process, what is happening in the backend. Okay. What is Delta Lake actually in data analysis in one word? Delta Lake is the place where you can bring your data in the raw format and you can write them into the tables. You can connect your Power BI, Tableau, everything to those tables. It will be easier analysis rather than connecting to the raw data. It is a single platform where you can bring your data in raw format, you can transform, and in the same platform, you can save your data in structured format. That is Delta Lake. Clear, guys? See, you bring raw format of data, save it as it is, you transform, and you finally save it in some structured format. And all you can do on your Delta Lake on one single platform. Coming back to our discussion. Yeah, data warehouses, data lakes, or different kind of storages. They are used for analytics. Data lakes, data warehouses, data lake houses. They are designed for analytics. Your databases like MySQL, Postgres, Oracle are designed for transactions. So in MySQL database, you're having some data, let us say product data. Whenever a new product is came into the stock, you have to update the number of products available. So the regular transactions you can make easily and very often happen to these transactional databases. But when coming to analytics data, you will collect real-time data or historical data. There won't be much changes to that data. Suppose if you are getting sensor data, that is it. You will not make changes to the attributes of it, values of it. Suppose you are getting some order details into your tables. You'll get them as it is and you will make analytics on them. You'll not try to update the values. You are not interested in transactions. You are interested in analytics. So very little. It doesn't mean you should not update your data at all. Very little updates will happen in here to the data. I mean, making changes to the existing data, existing values. So Delta Lake is also built for analytics. Whenever you put data, it will be saved in Parquet format. Especially when you want to create table out of that data, first Parquet files will be created. And these files are immutable. They are immutable. Even in your data lakes, you cannot make changes to the data. You can delete data, you can read, you can write. Once you put some data into your data lake, you cannot edit it. You can extract it and edit it in a different platform. But in data lakes, you cannot directly do that. Same thing here also. But it is not only data lake, there is a data warehouse part also. What happens here when you want to update your table? Let us say in earlier example, Alice has updated two files, part 1 Parquet, part 2 Parquet. Now what is she doing? She is updating. She is adding a data file. Part 1 and read and update. She is also updating part 1 Parquet. So there are two files which she already inserted into the Delta Lake. And there is a part 3 Parquet also. Now what she is doing, she is not creating this part 3 Parquet. She was just trying to update her earlier insert, which is in this file, part 1. She is trying to update it. but here they are immutable. So what Delta Lakes does is it creates a copy. It creates copy of part 1 and it make changes to that part 1. When update operation comes and it has to be done in part 1, it will create part 1 copy. And whatever changes are there in this update command, that will be applied. Now this part 1 copy will be saved as part 3 after applying the changes. It will become part 3 file. Now all these data will be available in transactional logs. Copy has been done to part 1. Why? Update instruction came. And this attribute has been changed. She was interested in updating some value. So that value, that particular change is applied. And then after applying, that is treated as part 3. All these will be available in these log files. Now Bob again trying to read data, select everything from table. This will not directly go to table. This SQL statement first will go and verify the transaction log. Now they understand that there has been some changes. Update happened. Now instead of reading part 1 and part 2, part 2 and part 3 files will be given to as a response to the SQL query of Bob. Because part 1 is updated. Part 1 is still there in tables directory, but hidden. Now it is part 2 and part 3. Now the key here is the transaction log for read requests. Now if read requests, they don't go through this transaction log, they will not understand. That is how Delta Lake managing updates. So it's next step of data lakes. In traditional data lake, once you put data, that's it. If you want to change it, you download, make changes. The changed version, again, you can put it in your data lakes. Delta Lake has this facility because of transaction logs. Clear, guys? Let us take one more scenario. Concurrent writes and reads scenario. Here what is happening? Alice is inserting some data into the table. When she trying to insert in the Delta Lake, first all the data will go as part 4 parquet. And eventually this part 4 parquet will reflect into the table. But still it is in the process. While it is in the process, Bob is trying to get all the data from the table. Now, what happened? Keeping all the things that Alice has done to the table, she updated the part 1. So now part 1 is actually part 3. And part 2, she has made insert and then it was not changed. It was like that as it is. Now Alice was trying to put part 4 parquet, which is nothing but rows in the tables, but in the backend, they will be saved as part 4 parquet, like that. She was trying to insert some rows in the backend part 4 parquet. They are incomplete. While it is in the process, at the same time, Bob requests, right? What request first will do? It will go and read the transaction log, these files. First, there is a JSON file where Alice has inserted the data. It is that insert metadata will be there in the JSON file. And then she updated this part 1. That data will be available, update data here in this log. Now she's trying to insert some more data. which is this one, transactional log. But this transactional log will not be available until she finish writing part 4 packet. When Bob tries to read the data, first it checks the transaction log. This will not be available. Only first 2 logs will be available. According to first 2 logs, Bob will get part 2 packet, part 3 packet. After some time, he again tries to select everything from the table. This time, finished writing. So this another transactional log file will be available. When he requests everything from the table, tries to read everything from the table, the query will go and check the log file. Now log file will be having 3 JSON transaction logs. One is the first insert. This is related to update, and again insert happened. That one. So it will get all the data result. And that is how Delta Lake manages both lake part as well as the warehouse part, tables part also. And that too with ACID transactions. See, now concurrent read-write scenario, there is no conflict. ACID is nothing but atomicity, consistency, isolation, durability. In isolation, what databases do, when some write request is happening, they'll not allow read request to conflict with that write request. And the same thing is available in Delta Lake. Right. Okay. When data is failed write scenario. Whenever insert fails, it's simple to understand. Whenever insert into table fails, you see the JSON will not be created, just like in earlier scenario. Only when insert happens, a new JSON will appear here. So if it is a fail, the transaction log will also not be available. A half uploads. For that also, it will not create transaction log. Only when complete insert is happened, transaction log will be available. In that way, there is if there is any half uploads, messy data, halfway data, it avoids a read request to reach such kind of messy data, dirty data. Because of this, the one more thing, transaction logs, only they appear after that particular transaction is complete. So that is transaction logs, guys. And using these transaction logs, Delta Lakes, they manage tables effectively. Now let us look into the hands-on part. For that, I'll take you to my Databricks account. Okay. Databricks, it's a platform where you have the Delta Lake. That means it allows you to save your files, and also like how you write and query data in tables, in databases, data warehouses. You'll write data into tables. When you have data in tables, you can query it. And in this querying part, you have two things. Querying, you have transactional query and analytical queries. And now we are talking about analytical queries. When you have your data, you can make analytics through your SQL queries rather than flat files. Now I created some notebook here in Databricks Community Edition. I'm using the Community Edition, which is free. Everyone can make use of it. When you want some features, like you want to collaborate your Databricks with some other cloud platforms, and you want to build some machine learning platforms, you want to do extensive ETL, then you want to upgrade your Databricks to licensed version. You can explore Databricks for free with certain limits. Databricks is not just storage, they also provide the platform. You can see my cluster. What I am getting from my cluster, runtime. They are providing 15.25 GB of memory and 2 cores of CPU computes are available. You can process your data using that. Okay, so you can do all. You can store your data, you can process your data. In this processing part, if you are a data engineer, you can do your ETL processing. If you are a data analyst, you can do your EDA part. If you are a data scientist, you can try to build your machine learning processing using various algorithms. All are supported in Databricks. Now we are focused on understanding the concept of its storage, that is Delta Lake. And we talked about few things, how Delta Lake is actually managing tables. We talked about some scenarios. Now we will do the hands-on part. First, I'm saying use catalog Hive Metastore. In all Databricks, Hive Metastore is a catalog. Right? This catalog will have metadata related to the tables, files, everything. I'm saying use that catalog called Hive Metastore. That is default one. So we are not creating it. Rather than we are directly saying use. And if you observe here on the right side of this cell, there is Python. You can run your Python code. You can run your SQL code directly. You can run your Scala code. You can run your R code, and you can run your PySpark code. Databricks, when it started to host environment for PySpark, and eventually it builds its empire into AI, machine learning, and other things. So all these languages you can run here. Just click on new notebook. Suppose you want to experiment with machine learning, then yeah, you can create experiments. You can add your data. You can directly bring in data sets. Now coming back to our notebook, I'm saying use SQL Hive Metastore. Already my cluster is there. When you try to run the cell, if cluster is inactive, it will try to create and assign one. No, if you want to create cluster on your own, just more, you can create cluster and then you can come and run the things here. Okay, run. Since this platform supports multiple languages, you have to mention what language you are using. %SQL, it's a SQL command. It says okay. Now all the tables, everything I create here, they goes into Hive Metastore. The metadata will be saved there. I am creating a table called product info with these attributes: product ID, product name, category, price, and quantity. And I'm saying using delta. Suppose if you don't mention this also, it will work. Just an additional step we are saying, use the delta storage. Run it. See, the result is stored as SQL data frame. And it can be used in other Python cells. Now the table I have created, I'll use a table. I'll insert some data into the table. See, 3 values. I am inserting 3 rows. That means in the backend, some 3 Parquet files. One Parquet file here, and then 2 Parquet files will be there, not 3 Parquet files, because this insert will create one Parquet file. You can assume this as part 1 parquet in our discussion. See what Alice has done. First, she inserted some data. We are also inserting. We are inserting as two things. So this will go into one parquet file, and all these will be in one parquet file. In backend, there will be two parquet files. And you can see number of affected rows, but in table, there are 3. Why 3? 1, 2, 3, and 4. Number of inserted rows. Okay, let us see. But we have all the data. The first insert and 3 inserts. We have all the 4 rows. But when the insert happened, it somehow give that there are 3 rows. Maybe we have to run them separately, these inserts separately. So then it will show that number of affected rows as 4. So what is happening? It's not showing the first insert details case. It is missed out. It's only showing the affected rows for the second insert. Suppose if you run in 2 cells, then you will get to know. Both of the inserts will give you a separate result. And when I try to read everything, right, I got all the rows. Like how Bob has done to read everything. When this request I send to Delta Lake, first it will check the transactional logs. And the transactional logs leads to these Parquet files, 2 inserts. Sorry for the disturbance. Okay. Now let us check the detailed product info. Product info is a table name. And you can see the information. This is Delta, underlying storage, and ID of it, and where it is coming from, Hive Metastore. That's what we have given in the first cell. And it's a default Metastore. And you can see DBFS, which stands for Databricks File System. This stores data in file format. Your data can be visible in tables, in this table from Hive Metastore. And I'm talking about the Parquet files in the backend that will be in DBFS, Databricks file system. And you can see the time, last modified thing, number of files. See this thing, number of files, 2. Why? 2 inserts happened. 2 inserts happened, so 2 files. If you see, the rows are 4, but files are 2. Size in bytes and other details. And this is, we are using %fs. You can see what %fs means. %SQL you will use when you want to query your table. When you want to know, when you want to interact to the data lake part, you have to say %fs, file system. Let us run this. See, there is product info delta log, and 2 logs are there because we have done 2 inserts, 2 log files. Right. Sorry, these are not log files. Delta log will have log files. Parquet files. We have inserted two that will be saved as Parquet files in the file system. That is those two files. Now let us make update. Now table looks like this. I'm changing the price of, I'm increasing the price, adding 10 to the product which is having product ID 3. I'm not adding any new row here. I'm making the update operation. Now let us describe the product info. We are describing the table. You can see number of files is still 2. Size in bytes. Table features append only, statistics. Expand it out. Okay, here log files are not visible to us. We have made an update. Now let us run this, describe history. Yeah, in history you can know. You don't have access to actual log files, but you can know the history, what happened. We created table and inserted two times we have inserted. One time we have inserted only one row, and in the second insert we have inserted 3 rows at a time. And just now, just before this, we have done update operation. So all these are coming from your log file. Okay, and cluster ID you can see. And %fs. When you see this %fs, that means you are running this command in the file system part. There is data lake part, data warehouse part. When you use SQL, you are querying the table. When you are using FS, you are interacting with the data lake. Which language is this? This one, this is similar to Linux. You cannot perform any kind of processing directly. You can read, write, and if you want to delete files directly, you can delete. Those kind of things you can do using %fs. If you want to make changes to the file, then you have to make use of Python code. All these languages are supported: Python, SQL, Scala are. Along with that, you can run some commands to access the files in the file system, that is the lake part. So what kind of commands? Listing out, checking the file size. If you want to delete, yes, you can delete directly from the file system. These kind of operations you can do using this. There is no special language. If you are someone who are good at Linux, these are closer to Linux, almost equal to Linux commands. Whereas above language, anyway, you know, it's SQL. See, I am trying to give, LS stands for list out. I'm saying list out the things in delta log. See, the transactional log we are talking about, that is delta log. See, we have JSON, and then some associated file. Along with JSON, there is some other CRC file. First, we have made created the table, and we made insert, second insert, and then we updated. So 4 JSON files. created table. This is first insert, second insert, and after that we made update. And for the same JSON files, there is a .crc file also, log file. Now, if you want to read it out, if you want to know what this .json file contains, this is the command. Head gives you first 5 rows. It will not give you the entire file. Just give me a minute, guys. Right. Let us run this. It has the information. See, this file is about metadata. You can see when this third operation, in the sense update, the last one we have done is update operation to the table. And you can see the same. Operation is update, operation parameters, what we have done, what we have updated, notebook ID, cluster ID, and all other metadata surrounded to that will be there in the JSON file. Clear? Now let us wind up the things. Yeah, we will conduct a series of webinars. Our upcoming webinar will also be about Databricks. There we will understand about Databricks. We started understanding Delta Lake. That is the first step. That is the storage behind this platform called Databricks. Now, if you go and search about Databricks in Google, it will say it as AI platform. Meaning they provide this Delta Lake where you can bring your data. It can scale up to terabytes and petabytes. And you pay for what you have used once you get the license. The underlying infrastructure, everything will be managed by Databricks. And they'll also manage the Delta Lake part. On top of that, you can bring your data in the raw format and also in the tables format. Then why Databricks is calling it as an AI platform? Because of their processing platform. See, now I created notebook. I was able to run SQL code. I can run Python code. I can run PySpark code, Scala, R, everything is supported. Now you decide what is your processing. You can do that processing here. Once your processing is done, the transform data, your wish. You can put it in the file system in raw format as a flat file, or you can save it in their tables called delta tables. Delta tables, delta file system. And for each delta table, the things which you put in the delta table, in the backend storage in the file system, they will be saved as Parquet files. And for each operation you do on the delta table, there will be a log.json file. That's what we discussed so far. That's the summary of our discussion. If you have any doubts, you can please ask us. Okay then. Take care everyone. Bye-bye.